Hello, and welcome to the Paradox Showcase presentation. My name is Jacob Oriana, and I am the squad lead of the Paradox team. This project was a huge learning experience for myself and the rest of the team, so thank you for listening to our presentation. I'd like to start off by giving introductions on who is involved in the project. First, I'd like to introduce Dr. Peerbone. Dr. Peerbone is the project owner and sponsor of our project. Dr. Peerbone worked in collaboration with the Rebionics Lab out of the University of Maryland. He also worked in collaboration with the Semiconductor Research Corporation and the National Science Foundation for this project. Next, I'd like to introduce some of the members of the team. Brady Garvin, our tribe lead, and Melanie Krugler-Wright, our project manager, were extremely helpful in mentoring the team throughout the year. Dr. Peerbone, our project owner and sponsor, was the main stakeholder for our project. Tyler Barker and Kartik Gorma are grad students that work directly under Dr. Peerbone in his research at the University of Nebraska. These two grad students were instrumental in teaching the team the research aspect of the project. Next, I'd like to introduce the team. Like I mentioned, my name is Jacob Oriana. I am the squad lead and development manager of the Paradox team. Rustin Haas, our product manager, was extremely helpful in creating the vision for the project. Nathan Dewar, Bo Hatavi, Robin Buma, and Tyler Zinzemaster were all developers that worked tirelessly on this project. Now I'd like to give a little bit of background of the Paradox project. Paradox is under the umbrella of the Rebionics Lab out of the University of Maryland. This research lab focuses on creating devices that enable bidirectional information between living cells and electronics. They create first-gen devices that transform and enable telemonitoring, remote autonomous drug delivery, and environmental monitoring for agriculture. They recorded information on how layered biological substrate reacts to an electrical signal. They ran the physical trials to form the basis of the Paradox simulation. Additionally, they provided feedback and requested features as our project progressed. So what is Paradox? Paradox is a project that connects bioelectrical simulations to an easy-to-use online interface that fulfills these tasks. Accelerating the rate at which results from oxidation redox reactions can be gathered, connect our simulation to a greater audience, expedite the research process of bioelectronic interfaces, display simulation data in a fluent and easy to understand way, and lastly, remove the need to run new physical trials for a set of parameters. Now I'd like to talk about the problem and opportunity of our project. The problem we were faced with was designing an application that accurately shows how a simulated system reacts given a set of stimuli or parameters. We were faced with the problem to allow a user to add a new simulation data to the system so that other users can access it. We also wanted to be able to allow for experimental lab tests to be uploaded to the Paradox system. This gave us the opportunity to create an application where users able to, over the web, run the simulation and see output data after providing a set of parameters. We also had the chance to create integrated graphs that display simulation data or experimental data when uploaded to the system. And lastly, we had the opportunity to create an interface where the user is able to create and store species data that other users across the globe will be able to utilize. Now I'd like to give you a demo of our solution. Here's the interface that we created. It is currently hosted and served for anybody to access. As you can see to the left, here's the interface that the user is able to, where a user is able to adjust the parameters of the simulation and run it based off their choice. To the right here, we have the graphs that display the simulation data. On the top, we have current and voltage graphs, and on the bottom, we have concentration graphs. These two graphs display different data that make it easy for the user to understand how the simulation ran based off the parameters that they input. A user is also able to log in using their credentials to add or delete species that they can then use in the simulation. Additionally, the user is able to load experimental or simulated data to our interface and display it on these graphs. Now I'd like to talk about the value and highlights that were taken away from this project. This project gave us the opportunity to work on creating the supporting framework for a continuously altered simulation. We were also able to develop a wide range of knowledge and experience in regards to web app development. We were able to work professionally within a team and directly with our sponsors, and we learned how to adapt to changes in scope and technologies that were utilized in the project. Some of the highlights of our project are creating a custom web interface for researchers at the University of Maryland, which will help their research into the novel field of biological computer interactions. We were also able to implement new functionalities such as multi-species support, thanks to our collaboration with our sponsors and stakeholders. Our web interface is a backbone upon which new development may be added to improve the functionality of this tool in the future. Thank you for listening to our presentation, and I will open it up for questions.
Thank you. Thank you for your presentation. I, as a sponsor, have a couple of questions. So my first question is, what does this product, what use does this product have for stakeholders and in furthering the understanding of the electrochemical experiments it simulates?
The software allows for the University of Maryland researchers to generalize their findings of experiments to quickly find better solutions for the use of bioelectronic devices without having to run large amounts of costly lab experiments. In short, it will cut down the time and cost requirements for them to find ideal biological or biochemical solutions for their rebionics project.
Thank you.
I have a question for you guys. Good job on your presentation. Does the name PaRedox mean anything in particular?
Yeah, actually. PaRedox was the name chosen by our sponsor who was just speaking, Dr. Pirabon, and it's short for a software for parameter-based design and optimization of redox-enabled bioelectric devices, electronic devices.
Okay.
Which is a bit of a mouthful. PaRedox sounds a bit better.
Okay, thank you, Tyler, for explaining that. So I have another question. So what features can we hope to expect in the future from your application? I know that some of you will be actually joining me in the summer, so I'm really eager to know your plans on developing further this project.
The current features we have planned for the near future, that would include parameter optimization, which would be searching for the best missing attributes based on the attributes input by a user. A 3D heat map to visualize a change in concentration in 2 dimensions from a voltage source. And finally, we plan on potentially supporting different types of periodic input voltage signal functions, including sine waves, etc.
Perfect. Thank you. Very interesting. I'm looking forward to that.
Quick question on follow-up of that. So I wanted to know why the application is laid out the way it is currently on the website.
Yeah, sure. Much of the current layout is based on the design suggestions given from our sponsor, feedback given. And they're separated into tabs for simulation and upload, which helps separates the functionality of the programs and to keep it simple for the user.
All right, thanks.
I have a question. So what's the background knowledge of the development team from both the perspective of coding and electrochemical understanding?
All right. When we started the project, we all had decent experience with coding from our various computer science, software engineering, computer engineering majors, but none of us had very much experience with electrochemical processes. So we had to take some time near the beginning of the project to learn the fundamentals of that, just so we could understand the project fully and apply it to make this application.
All right.
So I have a more technical question. What kind of tools did you guys use while developing the server?
So for our server, we used Apache to host our React front-end framework and a Django back-end framework. The simulation is ran in MATLAB with a Python script in the back-end. And they're all connected like as if these things are layers.
Okay, thanks.
Okay. Well, if there are no more questions, I just wanted to thank you all. It's been an amazing experience, and I'm proud of you and of the way you adapted to the new situation where we have all been forced into. I'm just looking forward to seeing more and more from this app. Of course, from the side of NSF, that is a great step forward for our project, and it's useful. And I already had very, very positive feedback from our stakeholders in Maryland. So thank you very much for this experience, and I wish all the best for all of you.
Yeah,
Thank you.
Yeah, great job, guys.
Thank you.
Thank you.